Hi, my name is Tally, and in this screencast, I'm going to investigate the older roller coaster dataset using CODA. The investigation question I'm exploring is, how tall do older roller coasters tend to be? I'll walk through the dataset, show how to sort values, create graphs, add statistical measures like the mean and median, use movable values, recolor by coaster type, and explore a relationship between height and track length. I'll explain each step as I do so you can see exactly how CODAP supports statistical thinking. When I open the codec file, as seen on the screen, it starts in case card view. Each card represents one roller coaster and includes variables like the coaster name, park, type, year opened, maximum height, and track length. I can flip through the cards using this arrow, and this shows all the different 31 roller coaster cases in this data set, and I can expand it by this so you can see it bigger. Now I'm going to switch to table view by clicking on this table icon. This shows all 31 coasters at once, which is helpful for sorting and comparing values across the whole data set. And again, I can just expand it in this thing in the corner. Before I graph the data, I want to get a sense of the range of heights. I'll start by sorting the max height column. So as I'm in table view, I click on the max height variable and choose sort ascending. Now I can see that the smallest coaster height appears at the top at 18 feet, which is this high speed coaster. And then if I scroll down to the bottom, I can see the tallest coaster in this set is this coaster at 148 feet. Sorting helps me quickly identify the extremes before I move into graphing. Next, I'll create a graph of maximum heights. So I'll click the graph icon at the top, and again, I can expand the graph to make it bigger. So I'm gonna drag the max height from the table and drop it on the x-axis right here. And then now we can see each dot represents one roller coaster's maximum height. So if I just click on this one, I can see it. So for example, this dot I clicked on is shows its max height at 18 feet and it's the high speed thriller coaster. And this is the smallest height in the data set. And then if I click the point at the far right, I can see this is the tallest height in the data set at 148 feet. And these are extreme values in this distribution. Now I'll add movable values to highlight what's typical. So on the graph, I can click on this little ruler icon and I go down to the plotted and movable values and I'll click add movable value twice. This gives me two vertical lines with a shaded region between them. So I'm going to drag one to about 60 feet and the other one to about 100 feet because this is kind of just showing the middle distribution of the data set. So let's get it at 100. And then next, I'm going to click the ruler icon again and turn on count and percent. And this tells me that 16 coasters, or about 52%, fall in this shaded region. This helps me describe what's typical for the older coasters in this data set. Next, I'll add some statistical measures. So on the graph, I'm going to click the ruler icon again, which is still pulled up, but if I just click it again, I can click on mean, median, and then go down to box plot and click on box plot. So if we scroll in a little bit and just click on these lines in the middle, I can see the median is about at 80 feet and the mean is at 80.9 feet. So the mean is slightly higher, which makes sense because the distribution is a little bit right skewed due to the very tall um, steel coasters, which we're gonna examine in a minute. And we can also see the IQR runs from roughly about 70 to 102 feet, showing the middle 50% of the data. So a typical older coaster is around 75 to 85 feet tall, with most falling between this kind of like 70 to 100 feet range. So now I want to see whether wooden and steel coasters behave differently, kind of as I just mentioned. So in this table, I'll drag the type attribute to the middle of the graph. So let's just drag it. And then now I can see the wooden coasters cluster tightly between about 60 and 100 feet, as seen here in these purple dots. And then the steel coasters show much more variation, including both the shortest coaster at 18 feet and the tallest at 148, represented in the orange dots. This kind of suggests that steel technology allowed for more extreme or experimental designs, as like there are extreme values in the data set. Next, I'm going to explore whether maximum height and track length are related. So I'm going to drag the track length variable from the table and put it on our y-axis right here, and we're going to keep max height on our x-axis. Now I have a scatter plot where each point represents one coaster's height and track length. So I can kind of see a positive association between taller coasters tending to have longer and tracks as the coasters are taller, obviously. So for example, we're gonna look at this dot, and this is the Beast coaster, and it's 110 feet tall and has a track length of 7,359 feet, which appears as a point far up and to the right on our graph. But then we go down here and kind of look at the short coasters. And again, this high-speed thriller coaster is only 18 feet tall and kind of has a smaller track length of only 200 feet. And this relationship makes sense because taller coasters often require longer track lengths to complete the ride layout. So just kind of like wrapping everything up we've explored in this CODAP dataset. Using CODAP allowed me to explore this dataset dynamically rather than just like a graph on pencil and paper. And I was able to sort the data, create graphs, add statistical measures, recolor by type, and examine relationships between variables. Based on the sample, older US roller coasters tend to be around 80 feet tall, and wooden coasters showing more consistency, and steel coasters showing greater variability. So this concludes my screencast, and thanks for watching.